So good morning. Today we are going to discuss about NumPy. So NumPy is a Python library used for working with arrays. NumPy stands for numerical Python. Now why we are supposed to use NumPy? NumPy arrays are faster and more compact than Python list. So an array it consumes less memory and is convenient to use. The array object in NumPy is called ND array. So in which language the NumPy written? So the NumPy is written in the language of C or C++. So when we try to install NumPy and if Python is already installed, so the command to install NumPy is pip install NumPy. So while importing the NumPy, once the NumPy is installed, import in its application by adding the import keyword. So import NumPy. So here is an example to import a NumPy. So import NumPy and we are declaring a new variable name ARR equal to NumPy.array of within the normal brackets. We are supposed to have a square bracket and within the square bracket we'll be having a collection of values that is 1, 2, 3, 4, 5. And when we try to print the variable name ARR, the output which we get is 1, 2, 3, 4, and 5. So NumPy as NP. NumPy is usually imported under the NP alias. So import NumPy as NP. Now the NumPy package can be referred to as NP instead of NumPy. It is just an alternative name. So here is an example. Import NumPy as NP. And in the next line of coding, we have ARR equal to NP dot array of within the square brackets, we have the collection of values. Now, when I try to print ARR, we'll be getting the output such as 1, 2, 3, 4, and 5. Checking NumPy version. So to check the version of NumPy, we have an attribute where the attribute is version attribute. So import NumPy as NP, print of NP dot underscore underscore version underscore underscore. And the current version of the NumPy is 1.25.0. Checking NumPy ND array objects. So NumPy is used to work with arrays. The array object in NumPy is called ND array. So create an NumPy ND array object by using the array function. Example, import NumPy as NP, ARR equal to NP dot array of within the square bracket we have a collection of values 1, 2, 3, 4, and 5. Now we are trying to print the variable name ARR and in the next line of coding we have print of type of ARR. Now here the output is it displays the collection of values and in the next line of output we have class numpy.nd array. So numpy in Python it is used to create ND arrays and using a tuple to create numpy array. So import numpy as np and ARR equal to np.array of we are supposed to use two square brackets and within the nested square bracket we have the collection of values 1, 2, 3, 4, and 5. Now this is a tuple. With the help of tuple or by using the tuple the arrays has been created. Now to check the dimension of arrays here we have 0D, 0 dimension, 1 dimension, and 2 dimension. So first we'll be discussing about 0D arrays. So 0 dimension arrays are scalars are the element which is available in an array. So each value in an array is an 0D array. So here the example is import numpy as np and in the next line of coding we have array equal to np dot array of 42. It is a single value. Now when you try to print ARR, the output which we get is 42. So this is an example to create 0D arrays. And one-dimensional arrays, we might have only the rows. So here is an example. Import numpy as np, ARR equal to np dot array of within the square bracket we have 1, 2, 3, 4, 5. Now when I try to print of ARR, the output which we get is 1, 2, 3, 4, and 5. So since it is one-dimensional array, we might have only rows. So here is an example to create 2D arrays. So here import numpy as np, ARR equal to np dot array of within the normal brackets, we should have two square brackets. In the nested square bracket, we have 1, 2, 3, comma, and one more square bracket, we have 4, 5, 6. Now, when I try to print this variable name, the output is 1, 2, 3 in the first row and 4, 5, 6 in the second row. So, since it is a two-dimensional arrays, we have both rows and columns. This is an example regarding 3D arrays. So, an arrays that has 2D arrays matrices as its element is called 3D arrays. So, they are often used to represent third order tensors. Now, creating 3D arrays with two-dimensional arrays, both containing two arrays with the values 1, 2, 3, and 4, 5, and 6. Now, here is an example. Import numpy as np, arr equal to, it's a new variable name equal to np dot array of, will be having three opening square brackets where the value is 1, 2, 3, and will be having one more square bracket 4, 5, 6, and we'll be having two closing square brackets, comma, we have two opening square brackets 1, 2, 3, closing brackets, comma, opening brackets 4, 5, 6, and at the end we have three closing square brackets. Now when we try to print array, the output which we get in the form of 1, 2, 3, 4, 5, 6, 1, 2, 3, and 4, 5, 6. Now when you take a look at this particular output, it is just two-dimensional arrays. Now to check the dimension of each and arrays, we have the inbuilt function where the function is ndim. Now regarding the first case, since it is zero dimension, when we try to print a dot ndim, the output is 0. And the next one is in one-dimensional array, and C we might have created a two-dimensional array, and D we might have created a three-dimensional array. So respectively, for each and every dimension, the output which we get is 0, 1, 2, and 3. Now to access the array elements, so array equal to np dot array of, within the square bracket we have the values such as 1, 2, 3, and 4. Now with the concept of indexing, print of array of 0, it tries to access the first value from the array. Now the next one is getting the third and fourth element from the following array and adding them. So import numpy as np, arr equal to np dot array of 1, 2, 3, 4. Now what we are supposed to do is we are supposed to access the third element and the fourth element from the array, and these two arrays has to be sum. So print of array of 2 plus array of 3. Now array of 2, in this index position, whatever the values which we have, that particular value will be accessed, and array of 3, the next position value will be accessed, and these two will be added, and the output will be displayed as 7. Now accessing 2D arrays. Now since it has both rows and columns, to access this we need the row number as well as the column number. Now here if you look at an example here, import numpy as np, arr equal to np dot array of, we have the collection of values such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when we want to access the second element on the first row, we are supposed to give array of 0, 1. Now, the other example is when we want to access element on the second row and the fifth column, we are supposed to give 1, 4. So here the output is 10. So ND array, the NumPy ND array class is used to represent both matrices and as well as vectors. So the different attributes of an array. So array is usually a fixed container of items of the same type and size. The number of dimensions and items in an array is defined by its shape. The shape of an array is a tuple of non-negative integers that specifies the size of each dimension. Now in NumPy, the dimensions are represented as axes. So the 2D array, it looks like we have two square brackets. So 0 dot, 0 dot, 0 dot. And in the next row, we have 1 dot, 1 dot, 1 dot. So we have both the rows and columns. Now to create a NumPy array, we might have used the function np dot array. So import NumPy as np, A equal to np dot array of, within the square bracket we can have the collection of values. Now this is the command, and how the values will be represented is, so in the right hand side we have an image, so the comment and the values will be represented in this particular form. Now the next example is creating an array with zeros. So import numpy as np, print np dot zeros of 2. So here we'll be getting 0 dot comma 0 dot. And when we can create an array filled with ones, so np dot ones of 2. So instead of 0 we'll be having ones. Good morning. Today we are going to discuss about pandas. Pandas is an open source Python library used for working with data sets. So it has function for analyzing the data, cleaning the data in a data set, exploring and manipulating the data in a data set. And the pandas library, it is built on top of the NumPy library. Pandas is fast and it has high performance and productivity for users. And to check the versions of pandas, import pandas as pd, and in the next line of coding we are supposed to give print of pd dot underscore underscore version underscore underscore. This is the code to check the version of pandas. And the next one is we are going to discuss about the advantages of pandas. So pandas are fast and efficient for manipulating and analyzing the data in a data set. And it has advantage of data. It takes data from different file objects which it can be loaded for analyzing as well as and manipulating. And easy handling of missing data represented as not a number in floating point as well as non floating point data. And the data set can be merged and joined by using pandas. It has a flexible reshaping and pivoting of data sets, and it provides time series functionalities. So these are few advantages of pandas. Now regarding the installation of pandas, once the pandas has been installed, once the Python has been installed, to install pandas, we can give the command pip install pandas. And after the completion of installation, the pandas can be imported with the keyword import pandas as pd. So this pd, it refers to as allies to the pandas, an alternative name. Now in pandas, there are two different data structures. One is series and the other one is data frame. A series, it is just like a column in a particular table. And panda series is one dimensional labeled array capable of holding a data where the data it can be of different data types. Now regarding creating an empty series, so series function of pandas. This is an inbuilt function which it can be used to create a series in pandas. A basic series which can be created is an empty series. By default, the data type of this series is float. Now here is an example to create an empty series. Import numpy as n, import pandas as p. where n is an alias for NumPy and p is an alias for pandas. Now declaring a new variable name ser equal to p dot series. Now series function, it is used to create a series in pandas, and moreover this series, it is often just an empty series, and it returns the data type of series as a float as default. Now creating a series from arrays. Now in order to create a series from NumPy array, we have to import a NumPy module and we have to use array function. So import NumPy as n, import pandas as p. Now declaring a variable name data equal to, first we are supposed to create an array. So data equal to n dot array of, within the square bracket will be, we can have a collection of data items. Now in the next variable name ser equal to p dot series of data. So a series has to be created from arrays. So p dot series of data. Now when we try to print ser, the output in the right hand side, it displays as we have 0, 1, 2, 3, 4 and the collection of data items which is available in the array. Now we can create a series from array with an index. So in order to create a series by explicitly providing an index instead of the default index value, so here is the source code. Import NumPy as n, import pandas as p. Now data equal to n dot array of, we have a collection of data items. Now in the next line of coding, this is the line of coding to create a series. So the variable name is equal to ser equal to p dot series of the data, comma, here we will be specifying the index value. Instead of taking the default index value, here explicitly we can define the index value. So index equal to, the index starts from 10 to 14. 10, 11, 12, 13, 14. Now when you look at the output here, all the index value, instead of having the default value such as 0, 1, 2, 3, 4, here we have 10, 11, 12, 13 and 14. Now creating a series from the list. So we can create a series from list. So first we have to create a list, and after that we have to create a series from the existing list. So here is the source code. Import NumPy as n, import pandas as p. Now list equal to. So we'll be creating a list. Now in the next line of coding, ser equal to p dot series of list. So here the series has been created from the existing list. Now creating a series from the dictionary. So in the previous case, we have created a series from the list. Now we can create a series from dictionary. A dictionary is a key value pair. Now from this key value pair, we can create a series. So import NumPy as n, import pandas as p. Now first we have to create a dictionary. Dictionary equal to a curly brace. We have the key as well as the value. And in the next line of coding, ser equal to p dot series of dict. Now when we try to print ser, a series might have been created from the existing dictionary. Now creating a series from scalar value. So in order to create a series from scalar value, an index must be provided. These scalar values will be repeated to match the length of the particular index. So import NumPy as n, import pandas as p. Now ser equal to p dot series of 10 comma. We are supposed to give the index value. Index equal to 0, 1, 2, 3, 4 and 5. Now when you try to print p, so for this value 10, the index position starts from 0 to 5, and in all this position, the value 10 might have been repeated. Now creating a series from NumPy functions. So import NumPy as n, import pandas as p. Now series 1 equal to p dot series of, within the bracket, n dot linspace of 3 comma 33 comma 3, where 3 is a step function. Now series 2 equal to p dot series of n dot linspace of 1 comma 100 comma 10. Now we can create a series from the range function. So ser equal to p dot series of a range of 10. Now for all these values 0 to 9, a series would have been created. Now the next data structure is, we are supposed to discuss about the data frame. Now before we discuss about the data frame, accessing elements from the series. So there are two different ways we can access elements from the series. One is accessing elements from series with position, and the second option is accessing elements using label, that is by using the index. Now in order to access elements from series with position, now here the series element refers to the index number, and we use the index operator, the square bracket, to access any element in a series. So the index must be an integer. So in order to access multiple elements from a series, we can use the slice operation. So the slice operation is performed on series with the use of colon. Now for example, here we are supposed to access the first element of series. So first we have to create a data equal to n dot array of CSE hyphen A. Now this particular data, it should be converted to in series. So SER equal to P dot series of data, and from this series the first element has to be accessed. So print of SER of 0. So 0, it talks about the index value, and from that index value whatever the data item which is available, it can be accessed. Now the next example is accessing first 5 elements of series. We have to have an array. So data equal to n dot array of, and this particular data, it should be converted into series. Now print of SER of, within the square bracket we are supposed to give colon 5. So the default index value is 0, and it takes up to 5 minus 1, up to the fourth index position. Whatever the data item which is available, everything can be accessed. Now the second option, accessing with the help of index label. Now here data equal to n dot array of, we are going to create an array. Now this particular data, it should be converted to in series, and along with this we are supposed to specify explicitly the index value. So we would have given index equal to, within the square bracket, 10 comma 11 comma 12 comma, it goes up to 17. Now print of series of 16 comma 11 comma 12. So in that particular index position, whatever the characters or data items which is available, everything can be accessed. So the output here is 16p, 11s, 12e, and accessing multiple elements by providing label of index. So SER equal to P dot series of n dot a range of 3 comma 9. So it takes the value from 3 to a, comma index equal to a comma b comma c comma d comma e comma f. Now print of SER of a comma d. Now whatever the value which is available in a and d, those value will be returned as an output. Now the next one is, we are going to discuss about data frame. Now data frame, so a data set in pandas can be usually represented in multi-dimensional tables. Series, it is just like a column, where a data frame, it is just the entire table. So pandas data frame, it consists of three principal components. It consists of the datas, it consists of the rows, and it consists of the columns. So the columns, it will be represented as a series. The entire table can be represented as a data frames. Now creating an empty data frame. So here p d equal to p dot data frame, and within the brackets we are not supposed to specify anything. Now when we try to print d, a data frame on an empty data frame might have been created. Now creating a data frame using numpy nd array. Now x equal to p dot array of 3 comma 6 comma 8. Now in the next line of coding we have df equal to p dot data frame of x. Now when we try to print a df, so a data frame might have been displayed as an output. Now creating a pandas data frame. First we have a list. So list equal to CSC, A, these are the different collection of items which is available. Now this entire list, it should be converted as a data frame. So df equal to p dot a data frame of LST. Now when we try to print df, a data frame might have been written as an output. Now the same thing it can be done to create a data frame from dictionary of ND array lists. Now dealing with the rows and columns. So in order to select the columns in pandas data frame, can either access the columns by calling them by their column names. So here we are going to create a data, and this particular data, it should be converted to a data frame, and from the data frame we are supposed to access the two different columns. The one is name column and the other one is qualification column. So print of data frame df, and within the square brackets we are supposed to specify the name of those columns. Now selecting multiple columns. Now instead of selecting one or two columns, we can access multiple columns with the help of slicing. So here we have a data, and that particular data, it has been converted to a data frame. Now df of df dot columns, and within the square bracket we are supposed to give the value such as 1:3. Now starting from the first column, and it reaches up to 3 minus 1 second column, all the columns will be accessed as an output. Now using LOC function. Now using LOC, we can select two columns. So we have a data, it has been converted to a data frame, and df dot location of 1:3, df dot LOC of 1:3 comma, and within the curly square bracket we have name comma qualification. Now based on this, these two columns will be accessed as output. Thank you.